Good afternoon, everybody. Thank you for being here and watching this session. I trust you had a good lunch too. Today I want to talk to you about machine learning. Machine learning, is it a black art or a blessing? Well, basically today I want to talk about it a bit. To a lot of people, machine learning does seem like a black art, and I want to demystify it a little bit. Now let me briefly introduce myself. My name is Vincent Vries, and I'm managing partner at OpsLogix. And basically at OpsLogix, we've been founded or established in 2009, and we started creating management packs for SCOM. And basically we started with the BlackBerry management pack, which is quite a while ago, and now when people actually think of BlackBerry, some of you have to laugh, but the thing is it's still around. But we basically, our most popular products, our most successful products were actually the ones for VMware and Oracle. So in 2011 we became a System Center Alliance partner, and we are actually proud of that for all the work we've done. But after a while we've been doing a lot of work in the OMS sphere too, and obviously with the event of the cloud we've been going there as well and productizing that as well. But so, on with machine learning. So why machine learning on SCOM Day? Well, first of all, we think machine learning has great potential for SCOM, which has not been implemented yet really. And I think people have looked at it a bit sideways, and you see that in OMS you have some parts of machine learning already. And we think it's really good, a really good combination with SCOM as well. So, basically, who has experience with machine learning in this room? Anyone? One person? Two? So, or, machine learning in SCOM or in any other capacity? No? Well, basically, I have to go back about 2 years or something like that. And, I kind of had the same blank look at my face when people talked about machine learning. So what I'd basically like to do in this session is share our journey and how we learned about machine learning, basically the basics of machine learning, just give you an overview and try to demystify it a little bit so that when you talk about it in the future, you can actually talk with a bit more confidence and you actually have an idea of what it's actually about. So what is machine learning? Well, let me first give you a definition of machine learning. There are a couple of definitions out there, but I think this is actually one of the best ones. Machine learning is an application of artificial intelligence, AI, that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Well, that's actually a great thing, because if we can program a system without actually being a developer, that makes life a lot easier on us because we can tell our systems what they should be doing, but we don't have to be a developer, we don't have to rent a developer. So that's actually really cool, it just learns our behavior. Now, you can see a bit of a blurry picture here, and which I took for an example. If we talk about machine learning, basically what we're talking about is a lot of algorithms. Now, you can't really read all of these already. The resolution is not high enough, I guess. But the thing I wanted to show you is that machine learning is nothing more than a bunch of algorithms, which a lot of people have taken from statistics or from other mathematical sciences. Now, if you look at this, both of these trees, there are so many different types. You can see them branching out in a lot of areas. And what I want to do today is I want to give you a few examples first of problems that exist and that you can solve with machine learning, and basically give you the classification of what kind of algorithm you could solve it with. So some examples. Most of you know simple regression. And most of you have had that at school at some point or something if you have taken statistics. And the very simple fact is that, for example, if you sell frozen yogurt and you want to know how much frozen yogurt you're going to sell on a certain day, you can look at the temperature, say it's 70 degrees or 80 degrees Fahrenheit, it's an American graph, so it's not in Celsius, you can see how many pounds of frozen yogurt you can expect to sell. Now, a lot of people would not expect that this is actually machine learning, but it is, because you can plug numbers into a computer and you can get a result. If you want to know from the weather prediction, so if it's 90 degrees, how much are you going to sell? Probably, well, you're probably going to sell around 80 pounds of frozen yogurt. Similarly, we can do classification problems with machine learning. So basically, if we wanted to sort out apples and oranges, we could draw these on a graph. And if we take the features like size or color of apples and oranges, we can kind of plot them out and we can tell them, well, this is an apple, this is an orange. And then what you can do with the mathematics or machine learning is draw a line, the green line through it. Now what happens if you draw a new data point, like the blue point there? Well, your computer can probably figure out that this is going to be an orange since it's on the right side of the graph. Hence a classification problem. Well, who's familiar with Netflix and the advisory function of Netflix? So basically what Netflix does for you is it tells you that, hey, you've watched all these kind of movies, you'd probably be interested in watching this other movie as well. Well, this is actually a collaboration-based filtering method. And what that is that people give their inputs on what they think of the movie. So if they really liked it, then it records it as 5 stars, or 1 star if you really disliked it. Now what you can do with this is that if you look at Ted and Carol, they both like movies B and C. So then we're going to try and figure out what Bob likes, or if he likes movie A or C. So we can see that Ted likes, gives a score of 4 to movie A, 5 to B, and 5 to C. Carol does a 5 for B and also for C. So what do you think, what movie is going to be recommended for Bob? Well, it already kind of says it, there are 2 scores of 5 for movie C. Ted scores movie A a 4. So probably the recommendation would be that Bob would be recommended movie C. Now, there's a whole new type of computer learning these days, which is neural networks. And I'll talk about that later on a bit more. But one of the earliest applications of neural networks was actually the recognition of handwriting. Now, at a lot of post offices, what they would want to do, they'd have a lot of staff sitting there sorting through all the envelopes every day and reading the postcodes and throwing them on a pile. And they thought, well, if we could use a machine for this, this would be so much better. And what they did, they created handwriting recognition, so you could read all the zip codes by machine, and it would sort them automatically. And basically, they used neural networks for this. So I've shown you a few examples of the type of problems you can solve with machine learning. Now, there are many more problems you can solve with machine learning. There's almost an answer for about everything. But all of these machine learning categories, they fall into about 3 categories. You have supervised learning, unsupervised learning, and reinforcement learning. Now let's take a look at the first 2, supervised learning versus unsupervised learning. If you look at supervised learning, what we do, we tell the machine in advance what the answer would be. So if we take the example of classifying things like apples and oranges, then we can say, hey, these rounds here, they're actually oranges, and these crosses here are apples. So when you make your next prediction, you can already reference my answers, and you can look at the graph, and then you can output the answer to me. So that's the way you actually train your machine. When you look at unsupervised learning, basically you give the, you don't give any information about the features of something. You say, hey, here's a raw data set, please figure out something, some features which it has in common. And then it'll actually cluster them automatically for us. And there are algorithms to do this. This is more complex stuff. But that's basically what unsupervised learning is. Now we have a third category, which is also not used that much which is a lot harder to implement. But basically, it's called reinforcement learning. And what you're telling your computer is if it made a good decision or a bad decision. Now, how do you tell the computer if it's been good or bad? That's always the hard thing. Well, let's go back to our Netflix example. And if you remember the rating system, basically to see for if a movie would be recommended for you, which is used for that, well, it uses it for much more, because it uses it for reinforcement learning as well. Basically, if you give 1 star to a movie, that would be considered a bad input, so you don't like the movie. Now, say that you already Netflix recommended a movie for you. I don't know, maybe Baywatch or something, and you watched it, and it was highly recommended for you. But then, when you watch it, you were kind of disappointed. Maybe Pamela Anderson wasn't in it, and you gave it 1 star. Now, this algorithm would learn actually say, hey, the prediction I made that this person was going to like that movie is actually not correct. So next time it's going to correct itself, so reinforce its own behavior. All right, so we did a couple of, quote, ordinary machine learning algorithms. But these days, you hear a lot about neural networks and deep learning. So I'd like to talk about them with you and kind of demystify these as well. First of all, neural networks can be used to tackle all 3 types of machine learning, because it's kind of a general toolkit to do so. And it works like our brain, hence the name neural networks. Now, our own brains are very flexible in actually solving tasks, so these should be too. Now, if we look at a neuron in a neural network, you can see here, this is what supposedly something in your brain looks like. We can see we have the neuron here. It has all these components, but basically what happens is you have inputs. And when these inputs are strong enough, the neuron can fire or it cannot fire. So basically, if it sparks, then it produces a charge here, electrical charge, and if it doesn't fire, it doesn't. Now you have billions of these neurons linked together in series, so in a whole network. And this is how it actually informs its logic. Now, when we do this, we can actually abstractify a neuron into something more mathematical. So we have our input neurons, x1, x2, and x3. And B would be our normal neuron. Now, we could say, we could ask the question, so when is this neuron going to fire? When is it going to reach Y? Well, basically, we can say, well, maybe if x1 and x2 fire, give our neuron an input, maybe it'll be strong enough to give B an output as well. Or maybe x3 by itself might be enough. So this is a bit of a strange situation. We don't really know when this neuron is going to fire. Well, let me give you an example to try and clarify the working of a neuron a bit more. Say that I'm interested in the cheese fest. I'm a Dutch guy, so I like cheese, so I'll go to the cheese fest every summer. But basically, I need to decide if I really want to go or not. So maybe my girlfriend is a deciding factor in that. If she comes with me, then I'd be much more likely to go to the cheese fest. If it's not raining, it'd also be more likely that I'll be going to the cheese fest. And since I like to drink some wine while eating cheese, also I'm interested in going by public transport because, I don't want to be caught driving drunk. So how do we solve this problem? Usually it's instinctually say, well, if my girlfriend goes, I'll go, regardless of the weather. But we can abstractify this a bit more, and we can make this like a neuron. So basically what we have on your left-hand side is all the input neurons, and we have a neuron there which fires a yes or a no to go to the cheese fest. Now what we would actually do is we would add weights to the different inputs of our neuron. And we also add a threshold to our neuron itself. So say that we need to surpass a threshold of 6 in order to go to the cheese fest? Well, basically, if my girlfriend would go and it's nice weather, then I have a value of 7, and my neuron would fire, so I'd go to the cheese fest. On the other hand, if it's sunny weather and the bus is going but my girlfriend's not going, well, it's too bad, my neuron is not going to fire and I'm not going to go to the cheese fest. So that is actually all a neuron does. Now, of course, you get all these neurons, you get them in series, so the input of one can be the output of another, so you can put them in series. Here. And here we have a formal definition of what a neuron would look like. So we have weights, and we add up all the weights, and if these weights actually trigger our neuron, then we get an output y. So this is the structure of neural networks in computer science, and also to some extent in our brain. We have our input layers, which were actually the ones, the bus, and basically girlfriend, and all the other things which we have. Then we have a hidden layer, and usually this is a layer of logic in between the input and output neurons. So you can actually fine-tune it more with more weights and more layers in between, which is called the hidden layer because you can only influence the input layer and you can only see the output layer. Now at the end we have an output. Here we have one output, but you can also have multiple outputs. So what's the difference between a neural network and deep learning? Well, you hear so much about deep learning, everybody's on about deep learning, it's so much better than normal neural networks. Well, deep learning is nothing more than actually multiple hidden layers between your input layer and your output layer. And that really is all. I mean, I can't make it any fancier. So this is the only difference dividing deep learning and neural networks, but we just use the fancy name for that. So what can machine learning do for us? I've just kind of scrolled through a couple of machine learning algorithms and neural networks. It's really too much just to tell you about in half an hour. You can fill days in talking about this. But what can it do for us? Well, let me give you a practical example. Say that we have a support stack. So we have first level support, second and third level support. But at OpsLogix we thought, hey, wouldn't it be cool if you could actually automate some of this support? And maybe all of the support, and that would be a dream, but at least the first level of support. So maybe we can use machine learning to automate this. And how would we automate this? Well, we take a machine learning algorithm, we kind of learn all the tasks, or we take out the alerts in SCOM, and we check these alerts in SCOM, what they're about, we can check the text, and then we attach an action to that. So basically we could do a disk cleanup, maybe, or we could restart the service, something easy like that. We start very easy. So these are all very mundane tasks you could automate, and which are not already in SCOM. In SCOM, what you do have, you have a recovery task, but these are very static by nature, so you have to program them in. And if you use machine learning algorithms, then it can actually learn from your behavior how you close alerts or what resolution stage you put alerts in. So let's go back to our classification problem. We see that we classified apples and oranges. Now, we can classify alerts too in SCOM. And of course, there are many more alerts than only apples and oranges, but it doesn't say you can't create more classes. So I'll give you a quick example. If we want to classify things like alerts, we can use a classification method which is already used in machine learning quite often, which is classifying of documents. Now, let's say we have document 1, document 2, and document 3, and we take all the words out of these documents and just put them in a long list. And then we give each word, we give a different ID. And then we also check in which document they appear. This is how we would actually classify all these words. Now, if we would run some statistical analysis on it, this is again, it's just an algorithm, then later on when we get a new document, we can actually find out which other document is most like it. So is the fourth document, question mark document basically, is it the most like similar to document 1, document 2, or document 3? Well, if it's document 2, then you already have a classification because document 2 is a classification. The same we can do for alerts in SCOM. So let's say we have the OpsLogix website full scan. Well, that could be the same as document 1. We take all the words out of OpsLogix website full scan, web application, the name, we can take the description, and so forth. And we can start classifying that. And let's make the classification, let's make that the resolution state in SCOM. So maybe we want to always close this alert. Well, then we classify this as a closed alert. And then we can use this methodology. So if we get a new alert, then you can, when it comes in, the algorithm looks at it, it's like, well, it's most like the first alert, so when we get in, we want to make it a closed alert. So we've already created a product like this, which can classify products, or which can classify resolution states. So basically what you would be doing is you'd be going through your alerts, and you'd right-click it, and you say, well, this particular alert I would always close, or you'd create a new ticket. So after a while of training, and it doesn't take that long, you just click through a lot, for a couple of minutes, then it starts recognizing all the words in an alert, and then it says, hey, probably because you closed this alert and you put that alert into the create ticket resolution state, I'll do the same for similar alerts when you let it go automatically. So that's one of the uses. But another use of machine learning tactics would be that we actually try to start correlating alerts. Now, our host Approved, they already have a method where they use predictive analytics to go through your SCOM environment. And what they do is basically they take all the alerts you already have and had, and they try to correlate them in time. Now, if you have multiple alerts, say you have alert A and B, and you know that after A and B appear, that you most likely get an alert C, well, maybe, the second time that you get alert A and B, you can already take preventative action to remedy something in your environment so that you don't get alert C. So as you can see, machine learning could actually help you in a couple of areas. It can help you automate stuff, but it can also help you prevent issues from actually developing. So I've pretty much come to the end of my presentation for machine learning. It might have been a lot in a very short span of time. I hope at least some parts of it, made sense to you. But what I really wanted to show you is that machine learning is not so much a black art. And it is just a bunch of algorithms which you can apply to a problem. Now, most of us are not mathematicians, so it might look a bit daunting. But if you look at it a bit longer, then it starts to make sense. Then also, I think machine learning has great potential for SCOM still. Because we have in SCOM, we have this huge amount of data, which we can start correlating or analyzing, and making use of to kind of automate tasks and even make self-healing systems. So if we can make these self-healing systems, we can start fully automating mundane first-level support tasks. We don't have to kind of restart the service anymore when somebody picks up the phone or clean up your disk space or anything else like that, which is just a routine task that you don't really want to be doing. And also, one of the things, we can start forecasting failures and taking preventative actions. So thank you very much for your time and listening to me. I hope, again, that it made a bit of sense to you, and I wish you a good day.